In section 11.9, we are working on finding representations of functions as power series. In this example, we need to find a power series representation for the function f of x equals 4x divided by 2 minus 3x, and then we will determine the interval of convergence. The basis for everything in this section is to know that 1 divided by 1 minus x is equal to the sum from n equals 0 to infinity of x to the n power for all x values that have an absolute value less than 1. This is really just the geometric series that we studied all the way back in section 11.2. Our goal is to write our function so that we see an expression that looks like 1 divided by 1 minus x, except this doesn't necessarily have to be just the variable x. Because I need a 1 in the denominator, I'm going to multiply the top and the bottom of this fraction by 1/2. So we have 2x divided by 1 minus 3x divided by 2. And then I could take that 2x in front and just slide it off. So we have 2x times 1 minus 3x divided by 2. So I've written f of x in this way that's more convenient. Looking just at 1 divided by 1 minus 3x divided by 2, we recognize it as the sum of a geometric series, the sum n equals 0 to infinity, or the ratio is 3x divided by 2. So we have this power series representation. Usually we split these powers up, so I can write this as 3 to the n power divided by 2 to the n power times x to the n power. And then our function f of x, we know, is 2x times the fraction 1 divided by 1 minus 3x over 2. So in other words, is 2x times the sum from n equals 0 to infinity of 3 to the n divided by 2 to the n times x to the n. And now what I can do is just take that 2x and slide it right to the other side of the sigma notation. So I'm thinking 2x times 3 to the n divided by 2 to the n times x to the n. And then combining, we get n equals 0 to infinity of 3 to the n divided by 2 to the n minus 1 times x to the n plus 1. This is our power series representation. Sometimes we like to see the exponent on the x being just n rather than n plus 1. If that's desirable, we could shift the indices and write this as the sum from n equals 1 to infinity of 3 to the power n minus 1 divided by 2 to the power n minus 2 times x to the power n. In my book, either of these answers would be completely acceptable. I did make another video about shifting indices because I know that that's something that can be pretty confusing until you're used to it. So please check that out. Let's talk now about finding the interval of convergence for this function. So we know that the geometric series converges only if the absolute value of that common ratio is less than 1. When we write our function using the power series, this really only works if the absolute value of 3x divided by 2 is less than 1. So to find our interval of convergence, we know that the absolute value of 3x divided by 2 is less than 1. Or in other words, 3/2 times the absolute value of x is less than 1. Or the absolute value of x is less than 2/3. Or x is between negative 2/3 and positive 2/3. So our interval of convergence is the interval from negative 2/3 to positive 2/3.